Hey there, people. We today are looking at section 7.4, which is on parallel and perpendicular lines. Parallel lines obviously are lines that never touch each other, they run alongside each other, and perpendicular lines obviously cross each other at a 90-degree angle, so perpendicular. And in particular, we're paying close attention to the slopes of those lines because that's what's going to make things uh, really relevant for us in terms of relevant in math, maybe not relevant in life. But uh, the nice thing is one of these is really, really easy, and that is, if you've already guessed, is parallel lines. The slopes of parallel lines, because parallel lines never touch, then their slopes are related in a very simple way. And that is the slopes of parallel lines are, can you fill in the blank? If you said equal or the same, you're right. Pat yourself on the back and give yourself a gold star because the slopes of parallel lines are simply put equal. They're the same. It makes sense, right? Consider this line here, which has a slope of, I believe it's 2 over 3. If I were to draw another line that is not on top of that one, I'm going to draw a different line that goes through a different point. I'm going to do it in black here. I'm going to pick this point right there. Okay? If I draw a parallel line, all I need to do is draw a line that has the same slope. So you can pick any point and just apply the same slope. So up 2 over 3. Or if you want down 2 and to the left 3, right there and right there. And if I just connect all those dots, we see, where's the one more up there, like that. Okay, these lines are parallel. They never touch, and they have the same slope, which is 2 over 3, rise over the run. Okay, so slopes of parallel lines are equal. So if you have two lines that go through different points, but they have the same slope, they're parallel. So here we have three equations of a line in slope-intercept form, and I'm looking for the two that are parallel to each other. Can you pick out the two? It feels like a little bit like a Sesame Street video, right? Can you find the right answer, everybody? Well, hopefully you recognize that these two are parallel because they have the same slope, 4. Okay? Now, the other similarity here is the y-intercept for both those is the same, but that doesn't mean that they're parallel. It means they go through the same y-intercept. That's all. So not the same thing. Okay? So there you go. That's parallel lines. The slopes are equal, which allows us then to spend the rest of our time focusing on a slightly more challenging one, which is the perpendicular lines. Now, it's pretty challenging to look at vertical and horizontal lines because their slopes are 0 and undefined. I not want to use those. And if I use a 45-degree angle going up or going down, the slope is either going to be, well, 1 or -1. So again, they're too simple to look at the relationship. So let me draw two different parallel lines, or sorry, perpendicular lines for you. Okay, well, believe it or not, these two lines are in fact perpendicular. Okay, and I'm not sure if it looks like that on yours. It sort of does on mine. Anyways, I know these are perpendicular. So let's look at the slopes and see if we can figure out what the pattern is. So let's look at the first. We're going to call this line going down 1, and the one that has a positive slope there 2. Let's look at the slope of line 1. So we're going to take the two coordinates that I have here, this point here, and this one right here, and find the slope between these 2 points. There are the coordinates. There is the slope, -7 over 3. And just as a rule for myself, I always put the negative on top. It's just easier that way, but you do it how you like. -7 over 3. Now let's look at the slope of line number 2. There are the points, and there is the slope. If you plug in the points, you get 3 over 7. So the slope of one line is 3 over 7. The slope of the other line is -7 over 3. Let's keep those two, that pair, in mind, and let's look at a different example and see if we can pick out a recurring pattern here. Okay, well, here is another set of perpendicular lines. Okay, let's pick out some points. Okay, so there we have 2 points on line number 1. Let's call that one up there. And one on the bottom we're going to call line number 2. Let's calculate the slope of line number 1 first. Actually, you know what? I'm going to pause, well, I'd like you to pause the video work out the slope of line number 1, line number 2, and see if you can see a pattern, a similarity between these two slopes and the two previous slopes we have written here. Okay, go ahead and see if you can do that now. All right, well, here we go. The slope of line 1 is going to be the difference in the y coordinates, so 8 minus 2 divided by the difference in the x coordinates, so 0 minus 1. In other words, 6 over negative 1. Okay, or in other words, negative 6. The slope for line 2 is going to be the difference in the y coordinates, so negative 6 minus negative 4. And the difference in the x coordinates is negative 5 minus 7. And so that's on top is going to be negative 6 plus 4, so negative 2. And then on the bottom it's negative 5 minus 7 is negative 12. That's going to be 1 over 6. Okay, so there's my 2 there. And actually it might be helpful to look at this one instead, and I'll show you why right now. So we have negative 6 over 1 and 1 over 6. So there we have our two pairs of perpendicular lines, and hopefully you can see the pattern, and that is this. Perpendicular slopes are negative reciprocals. Okay, reciprocal means you flip it, flip the fraction, which is why I wrote the negative 6 is negative 6 over 1. So I think about it as being a fraction, and negative, so switch the sign. So you switch the fraction, flip it, and then you switch the sign as well. So then if the slope of one line is 2 over 3, then the perpendicular line, well, flip 2 over 3, so 3 over 2, and then switch the sign. So it was positive, now it's negative. Okay? If you had a slope of negative 7, then the negative reciprocal of that, well, it's going to be positive. Think of this as being negative 7 over 1. So now it's going to be 1 over 7. Flip it and switch the sign. So just like last time then, can you look at these 4 different equations, this time not 3, and find the two lines that are perpendicular? I'll give you a second to do that. So hopefully you saw that these two lines are perpendicular. Let me show you how I know that. First of all, the slope on the left is 2 over 3. That's right there. And the slope on the right is going to be negative 3 over 2, which is from right here. And 2 over 3 is the negative reciprocal. In other words, flip it. So 2 over 3 becomes 3 over 2. And switch the sign so it becomes negative 3 over 2. This one is just the negative of the slope. It's not perpendicular. It's just the negative. And this one here is the reciprocal, but not the negative reciprocal. So it also is not perpendicular. It has to be both the negative and the reciprocal of the original. So this gives rise to some really interesting problems that you're going to come up, so you may as well learn how to do them. This is what we're looking at. So if I give you an equation of a line, this is in general form, 3x plus 2y minus 6 equals 0. You'd be asked to do something like find the perpendicular line. That's what this symbol means, perpendicular. Okay, find the perpendicular line that has an x-intercept of 9. So it's perpendicular to this line, but the x-intercept is 9. So the first thing you need to do then is figure out what the slope of your perpendicular line is. To do that, you need to find the slope of your original line. This does not really give me the slope just by looking at it. However, if you know what the ratios are, you can pick out the slope pretty easily. In this case, it's negative 3 over 2. Now, if you don't know how to get that, that's okay. Here's how you can do it kind of the longer way, just by isolating y and turning this into slope-intercept form. Okay, so I moved the 3x over to the right. Sorry, that should be a negative over there. And then I'm going to add 6 to both sides now. Okay, and then divide every term by 2. There's my line in slope-intercept form. There is the slope. That's the original line. So what is your slope of the perpendicular line going to be? Well, it's going to be the negative reciprocal of negative 3 over 2, which is, yeah, 2 over 3, positive 2 over 3. So I already know that the line has a slope of 2 over 3. But I also know that it goes through the point 9, 0. Because it has an x-intercept of 9. The x-intercept is where the y term, the y coordinate is 0. Okay, so I can write this in multiple ways. I could do it in slope point form, which looks like that, and then because it's just y minus 0, there it is there in slope point form. If I wanted this to be in slope intercept form for this one particularly, all I have to do is just do the distributive law here, and there it is there, y equals 2 over 3x minus 6. If I wanted to write it in general form, I could multiply everything by 3 and then move everything over to the right hand side. So there I have it in slope point form, slope intercept form, and general form. Okay, the perpendicular line that has an x-intercept of 9. So for your homework then, what I want you to do is to consider this line in general form and find the equation of the perpendicular line with the same y-intercept. So the same y-intercept, but it's perpendicular. So like they're perpendicular lines that intersect on the y-axis, in other words. I'd like you to write the equation of the line in all three forms: slope-intercept, general form, and slope point form. Do that for me for Tuesday's class, and I will see you tomorrow. We'll go over it all in class. But make sure you bring this one done, okay? See you tomorrow, or this morning, depending when you're watching this.